Welcome to this walkthrough of Azure Spring Cloud workshop. So this is a Microsoft Learn module on Azure Spring Cloud. So we're going to go fast through the introduction to go straight to the content. So first of all, you need to install the AZ command line. So it is already installed, and you need to log in. So you can do AZ account show to validate that you are correctly logged in. Once this is done, you might need, by the way, to install the specific extension for Azure Spring Cloud because it is not public yet. Once this is done, you will need to export a few environment variables. The first one is a resource group, so you can, of course, use the one that you like. And the second one is your Spring Cloud cluster name. This one should be unique across all of Azure. This is why I am typing a specific name so that nobody else is using the same cluster name. Once this is done, you can create the resource group in which we are going to work on using the AZ group create command line, and then you're going to create your Azure Spring Cloud cluster using the Azure Spring Cloud create command line. This can take a few minutes, but it is usually quite quick. In the meantime, you can configure to have by default the environment variables that we have just configured. So here we are putting by default our resource group and our Spring Cloud cluster name. That means that we will have less typing to do in the future for the next sections. So here I'm just alting the creation, setting up those defaults, and then running again my process. Once this is done, you can check your knowledge quickly and go to the next section. All we have done here is create a resource group and a cluster. Once this cluster is created, you will need a Spring Cloud config server. So a Spring Cloud config server is here to automatically configure your microservices. And of course, it is very important to do this and to have it secured so that your configuration data is secured somewhere, typically here on GitHub. So here we're going to create a specific Git repository that is going to be private, so nobody else can access it, and your configuration data will be secured there. So we are creating that repository here, doing a description, and we are going to click on private so that this repository is private. Now that it is created, we need to add some content inside that repository. So for that, we're going to copy here the command that is provided to us by GitHub. This is going to create a simple README file inside our directory. So we just create an empty directory. We are going to cd into it and paste that command that creates a README file. So now if you go back to your GitHub repository, you can just reload and you will have access to that data. Now we're going to create an application.yaml file. So this is a Spring Boot configuration file. So this is what Spring Boot will look for. So we're just going to use VI to create that file. We're going to copy paste this very simple configuration key, but that proves that your application is configured using Azure Spring Cloud. And we're going to git push that file to GitHub. So now when you refresh your GitHub repository, you will have this application.yaml file, which is available here. In order for your application to have access to that file, you will need to create a GitHub personal token because it is going to be secured. So for that, you need to go to Settings, Developer Settings, Personal Access Token, and here you can generate a new token. You will need, of course, your password because this is secured, and you will need to give access to your repository to that token. So here I'm creating that token here. I'm giving it access, and this is going to generate a token for me. You need to copy paste it from here because after that it will disappear because it is, of course, a security token. Let's go now to the Azure portal and have a look at our cluster. We're going to configure that cluster in order to access our secured Git repository. So first of all, we need to find our cluster. You can either use the resource group that we have created or go directly to the cluster. By the way, the cluster is not created yet here because we went very fast, but it's going to be created in the next few seconds. So we can already, in fact, start to use it. So here it is. And we are going to configure its config server using the Git repository that we have just created. So you just go to config server. We're going to give it the URL of the GitHub repository that we have just created before. So for that, we need to go to the GitHub repository that we have just created. So I'm just going back to GitHub here, go to my repositories. And the last one is the one we just created, and I can clone it here. So I'm taking this Git URL, I'm pasting it here in the configuration URL of our Spring Cloud config server. So by default, it is public. It is of course not what we want here. We want something secure. You can secure it using SSH or a public or a private token, which is what we are doing now. So the username is your GitHub username, so it's Jidua for me. And then the password is a token that we have just generated before. So you can go to personal access token and copy the token that we have here. And this is the token that we will use to connect securely to the GitHub repository. Okay, so now our Spring Cloud cluster is configured using a Spring Cloud config to get data from that secured and private Git repository. We're now going to be able to create some microservice which will get configuration from that Git repository. So this Spring Cloud config server can be public or secured through SSH or HTTP basic authentication. We use the third option here. And of course, it's a great way to secure everything and also to version your configuration. Now we're going to do our first Spring Boot microservice. For that, first of all, we're going to create our microservice using the AZ command line. So it's AZ Spring Cloud app create. So this is creating an empty microservice. That microservice is going to use a Cosmos DB database, which is configured using the MongoDB API. So we use Cosmos DB here because, well, there's a free tier, it's easy to use on Azure, and it's, of course, very scalable. But we will use the MongoDB API because most people will be familiar with MongoDB. And of course, it was great with the Spring Boot microservice. So we're going to store data for that microservice using the MongoDB API on top of Cosmos DB. For that, we will need to create a Cosmos DB database, which is what we do right now. Please note that this can take some time, so we are going to go forward and we will cut the video at one moment so it has the time to finish. It's going to take probably more than 5 minutes, but of course that depends on the state of Azure at the moment when you create your database. What we need to do next, and that's why we can move forward, is bind that Cosmos DB database to our application. So we have created an application A, which is empty. That's what we did with the command line just earlier. And when we click on our application, we can select service bindings. And service binding is a way to connect automatically your application to your database. What we mean here is that we will not need to configure the database password, that kind of thing. It's going to be handled automatically by Azure Spring Cloud. So your application will be able to connect to MongoDB without you having to configure the credentials or to rotate them. So you need to create a new service binding, select Cosmos DB. This is going to scan your available Cosmos DB databases. So it's going to find the one that you have just created. You need to tell the API type, which is Mongo, and this is going to automatically find your database and your security key. So there's nothing to do. You just need to click on create, and now your Spring Boot microservice is automatically configured with the correct credentials to connect to Cosmos DB. Now let's create that Spring Boot microservice. For this, we're going to use start.spring.io and with a few parameters. So you're going to use, of course, MongoDB, but we are also going to use Eureka and Spring Cloud config client. So we have service discovery and configurations that are automatically set up for our microservice. In order to use that microservice inside Azure, so we are going to open it up here, and we are going to modify its pom.xml to add a new Maven profile, which we call Cloud here. And this profile adds a specific Spring Cloud Starter Azure Spring Cloud client artifact. That artifact is used for your application to connect to the config server and to the discovery server inside Azure Spring Cloud. It gives you, in fact, the credentials to connect there. That's the only modification that you need in order for your app to connect securely to the discovery and the configuration server inside Azure. Now we're going to code our application. So it's a simple to-do application. So we create a to-do POJO, which has an ID, a description, and a done flag. We create a repository. So it's a Spring Data MongoDB repository. So this one is going to be able to automatically persist and query your MongoDB database using Spring Data. So there's like nothing to do. And then we're going to create a REST controller, so a Spring MVC REST endpoint that will be able to export that data, show that data using a REST API. So here is our REST controller, and we're going to copy paste this. By the way, this controller is by default creating 3 to-dos. So those to-dos will be created on MongoDB, on Cosmos DB using the MongoDB API as soon as the application is started. Now that our application is complete, we are going to build it using Maven. And once it is built, we're going to deploy it using the AZ Spring Cloud app deploy command line. This is going to upload the jar file that was generated. So upload it to your cluster, and it's going to deploy it, and it's going to run it. After that, your application will be running in the cloud, and we are going to be able to test it. That application will, of course, automatically connect to MongoDB, generate so the 3 to-dos that we have coded earlier, and we'll be able to query them and see that everything is running end to end. So our application is currently deploying. It's going to take usually a couple of minutes, probably less, because this one is a very simple microservice. By the way, if you want more power, you can, of course, increase the number of CPU or the amount of RAM of your microservice. But for something as simple as this, the defaults are of course, enough. And it is running now. And we are going to be able to go to the Azure portal in order to have a look at the application that we have now deployed and which is currently running. So if we go there, so it's the application that we have just generated, we can see that it is deployed and that we have a secured test endpoint. So this endpoint is secured using a specific token so that nobody can access it publicly on the internet, without the token, obviously. And if you do a curl request on that endpoint, you are going to query the REST endpoint that we have just generated. So this is going to access your REST controller, which will then query the Cosmos DB database, and this is giving you back the data that we have inserted in Cosmos DB. So here we can see that everything works. Our application was deployed, the REST controller is working, and the database is connected correctly. So congratulations, your first microservice is now running in the cloud. Now this microservice is secured, so we're going to create a gateway to have access to that microservice. So that gateway is basically the same thing as what we just did before. This is why I'm going quite fast here. We generate it using start.spring.io, and we add a Maven profile inside its pom.xml, so it's the same profile as we did before, so that our gateway can connect to Eureka and to the config server. We're just going to modify its application properties file in order to tell it to open up its routes to all the microservices inside our cluster. So by just putting that property, all our microservices will be publicly exposed through the gateway. And as we have just created one microservice, it will be, of course, exposed that way. Now we create our gateway as a Spring Cloud application on Azure Spring Cloud. Please note that we put is public true. So that means that our gateway will be publicly available on the internet, which was not the case for our microservice. And so we're going to do the same thing as we did before. Once this is created, we can package our application using Maven. So this is going to generate a jar file with our application, and then we can deploy it using Azure Spring Cloud app deploy. And this is going to deploy that microservice, that gateway the same way as we deployed the microservice earlier. The difference, of course, is that this gateway will be available publicly on the internet and will expose the microservice using a specific URL, which is in fact the name of the microservice in capital letters. So it is to-do-service for the microservice that we have created in the previous chapter. So here is our gateway getting uploaded and getting deployed to our Azure Spring Cloud cluster. Once it is deployed, we are going to be able to go to our portal to get its URL, its public URL. So this time we will not use a token that we had earlier, so we do not need to secure it. And that means we will be able to use a curl request to query that gateway. And if we add to-do service in capital letter at the end of that URL, well, then we will be able to query the microservice that we did before by going through the gateway. So here is the URL. So the gateway is getting deployed. It's going to be very fast because it's also very light. So we just need to refresh this a couple of times until it appears. And once it is deployed, we will be able to curl it and see the JSON data from the database that we have created earlier. So here is its public URL. So we can do curl, paste that public URL, and then add to-do service in capital letter to have access to the microservice, which is secured inside Azure Spring Cloud. And this is giving us, again, the same data as before. So we can see that the gateway connects to the microservice, which in turn connects to Cosmos DB, that everything works fine. Next section, we are going to add distributed tracing. Our application is currently not monitored using distributed tracing. For that, you just need to add in your pom.xml files, you just need to add one Spring dependency, which is Spring Cloud Starter Zipkin. It is a standard Spring Cloud dependency. It is not specific to Azure, but Azure will understand it. And so if you just add this dependency to your microservice and your gateway, well, both of them will get automatically monitored. And just by packaging them again and deploying them again, you will be, Azure will understand automatically those dependencies and will monitor your applications automatically. So here we are packaging and deploying again the microservice, and then we are going to do the same thing with the gateway. After that, we will need to wait a little bit, probably a couple of seconds until our monitoring is ready. And then just by hitting a little bit the refresh button or doing more curl request, well, you will see the monitoring working. So here is our microservice ready, and we're doing the same with the gateway. This is the screen that you will see once it is all ready. It's probably going to take a couple of minutes until everything is ready. So here is our application getting deployed. And now that it is deployed, we can go here to our cluster again and refresh it to see that everything is getting updated and deployed again. And if we do some curl request, we're going to trigger the monitoring, and see that, well, our application is getting monitored. So here I'm doing lots of curl requests in order to force distributed tracing to take place. We just need to open it up here. Oh, I didn't select it yet, so sorry. So we need to first create a specific application insights instance in order to store the data. So sorry, you first need to do that. And once this is done, we're going to be able to do those curl requests again in order to send data to application insights. So application insights is a service inside Azure that stores and processes that data. So as you can see that now it is being configured. We have access to the application map, which should be empty right now because we have not sent any data yet. And now we can send data again using some curl request. And so this data is going then, well, now to be monitored using application insights, and we will have automatically a map of our applications. So our gateway and our microservice will be available here. It takes a few minutes to process because we just configured it, but here it is already. So you can see that we did some requests to our gateway, and then the gateway did some requests to the to-do service, which is what we just did, of course. Now that we've got everything running, well, you can check your knowledge. Of course, it's very easy to add this. It's just a Maven dependency to add, which is a standard one. It's not specific to Azure. And we can go to the next section. We're going to scale our Spring Boot microservices. So at the moment, we just, well, created one instance of our microservice. But if you go here to Apps, To-Do Service, you can click on the Scale button here. By the way, you can also do it with the command line if you want to, but here you can scale it here, give it more CPU, give it more RAM, give it more instances, and if you hit save, well, it's going to scale your microservice accordingly, and so you can handle more load. There are many ways to automate this, and of course it will go better and better in the future, because the most important thing in a microservice architecture is to be able to scale it up or down depending on the load. Let's go to the next section. Oh, sorry, we're going to wait a little bit until instances start. We can see we've got one instance out of 6 here. And so, well, instances are going to pop up very quickly now because we asked to have 6 instances with, well, quite a lot of CPU and RAM. So if you just hit refresh, you need to wait a little bit, and your new instances are going to will be automatically running. Well, let's wait a little bit and we will see that later, but they will happen very fast. So now let's configure CI/CD. So what we did right now was deploy our applications manually. So that takes, of course, some time and some effort. What we are going to do now is push the microservice that we have generated to GitHub. So we are going to create a specific GitHub repository for our microservice. And we're going to put it private, of course. We're going to push our microservice there, and we're going to configure a CI/CD pipeline in order to deploy automatically to GitHub. So we don't have to do the Maven build and deployment that we have done just before. So here I'm just adding our to-do service to GitHub and pushing it there. So if you go now to GitHub and add the remote that we have created, you can just refresh and you will see the application available on GitHub. Here it is. So that's the application that we have created. You need to give access to our Azure Spring Cloud cluster to that GitHub CI/CD pipeline. So for that, we're going to need what is called a service principal. So for that, we need the ID of the resource that we have created. So here is the command line to get it. So that's the name of the resource that we have created. And once we have that resource, well, we're going to do that query to have access to what is called a service principal. So that will give us access to the clusters. That's going to give us some security code to have access to it. So here it is. You need to copy that JSON data, and you need to paste it inside your GitHub repository, inside settings, secrets, and you're going to create a specific secret. So that secret, which we call Azure credentials, is going to give access to your Azure Spring Cloud cluster to your GitHub CI/CD pipeline. Now we're going to create a GitHub action. So GitHub actions are the CI/CD system from GitHub. They are configured using a .github/workflows file, YAML file. So we're going to create that YAML file here inside our to-do service microservice. We're going to call our workflow springcloud.yaml. And you can copy paste what we generated here. What we are doing is basically doing a git pull to get your latest data, building everything using Maven, and then pushing everything to Azure Spring Cloud. Exactly the same thing as we did manually before, but now it's going to be automated using GitHub Actions, and it will use the credentials that we have just configured. So it's going to be able to do exactly what we did manually, but it's going to be automatic. And as you can see on push, this is going to work each time that you push some data to your master branch. So now what is going to happen is that you will not need to deploy or package anything anymore. You're just going to do git push in your code, and GitHub Actions is going to build your app and deploy it to Azure Spring Cloud without you doing anything. So it just needs a couple of configurations, like the name of your resource group and the name of your cluster, so that it knows where to deploy your app. And once this is done, you will just need to save that file and push it to GitHub, and GitHub will know how to build your app and deploy it automatically. So here it is. And once this is done, well, you need to push it and test it, of course. So I'm pushing it directly using Visual Studio Code, push to GitHub Actions and commit it and push it. Now that this is done, once it's pushed, you can go to your GitHub account to have a look at GitHub Actions to see if it is correctly processing that data. So if you go to your Actions tab, you will see that we've got the GitHub Actions that I have just created that is already running, which is getting queued and is getting started right at the moment. And once it's started, well, it will pull the data, package it, and push it to GitHub Actions. So it will be the last time that I will need to package and push my application to production. Also, what is interesting here is that we don't share secrets. So this can be done by a developer who doesn't have access to Microsoft Azure, who doesn't know anything about Microsoft Azure. He just needs to push his code, and everything will be automatically deployed for him without him knowing anything about Azure, about Cosmos DB. So it's very efficient for your developers. By the way, this first run is going to last a little bit because we don't have a cache of our Maven artifacts. That's why you see all the artifacts being downloaded, but we have set up a cache, so it's only happening the first time, and next time, well, the artifact will be already there, so it will be much faster next time that you push some data. So we need to wait a little bit until Maven builds everything, and as you can see next, it's going to log in to Azure Spring Cloud, install the Azure Spring Cloud extension, and deploy to Azure Spring Cloud. Of course, that depends on the load on GitHub Actions, but it's usually pretty efficient and pretty fast. Okay, it is built, and now it's being deployed automatically to Azure Spring Cloud. Now you can go back to your app and see that it is being deployed. By the way, you can see that we've got 6 instances. Remember that we scaled them in the previous section, so scalability worked also. And so congratulations, you have set up scalability and CI/CD, and everything works fine in your application. Once you got everything working, you can, well, don't forget to destroy everything, of course, because it costs some money. We put everything inside a resource group at the beginning, and that was on purpose. So now all you need to do is destroy this resource group, and everything that you have created will be destroyed. So you will not pay for Cosmos DB or anything else. Thank you.